Before us no longer lies only a pale red cold sky with two tiny moons silently passing by. Instead, above the horizon there could appear a thin, dark band of material stretching around the red planet. A ring made of rock debris and dust surrounding Mars, like a scar left behind after the death of a moon. And that moon is Phobos. Phobos is the larger of the two moons of Mars. A moon, and that moon is Phobos. But compared with Earth's moon, it is incredibly small. It is not round, not brightly shining, nor does it possess the gentle beauty of the moon we usually see in the night sky. Phobos resembles a misshapen, dark rock full of impact craters, like a forgotten remnant from the earliest age of the solar system. Yet this tiny rock is entering one of the most tragic destinies in the solar system. Because Phobos is not moving away from Mars, because Phobos it is gradually falling toward Mars. Every 100 years, Phobos moves about nearly 2 meters closer to Mars. That number sounds far too small. Within a human lifetime, we can almost never notice that change. But on the scale of cosmic time, millions of years are the blink of an eye. And if that process continues, Phobos will not exist forever. One day, it will come too close to Mars. Close enough that the gravity of the red planet will no longer merely keep it in orbit, but will begin tearing it apart. That is when the big question appears. If Phobos is broken apart by Mars, could Mars have rings like Saturn? The short answer is maybe, but not a magnificent ring system like Saturn's. To understand this, we need to go back to the story of Phobos, the moon whose name means fear. Phobos was discovered by astronomer Asaph Hall in 1877 together with the smaller moon Deimos. The names Phobos and Deimos come from Greek mythology. They are the two sons of the god of war Ares, corresponding to Mars in Roman mythology. Phobos means fear. Deimos means terror. Those names are so strange that they almost seem to foreshadow the fate of Phobos. Phobos does not resemble an ordinary moon. It has an irregular shape, measuring only a few dozen kilometers across, with a surface covered in impact craters. Most prominent is Stickney crater, a gigantic wound occupying much of the surface of Phobos. The impact that created Stickney was so powerful that it may have nearly shattered the moon itself. But that impact was not the end. On the surface of Phobos, there are also long, shallow grooves running across it, like strange cracks. For many years, scientists debated where those grooves came from. Were they fractures created by the impact that formed Stickney? Were they formed by material ejected from Mars? Or were they signs of something even more frightening? An increasingly attractive hypothesis suggests that those grooves may be signs that Phobos is being stretched, deformed, and gradually weakened by the tidal forces of Mars. What are tidal forces on Earth? We are familiar with tides caused by the gravity of the moon and the sun, but tidal forces do not act only on ocean water. They occur when one side of an object is pulled more strongly because it is closer to the source of gravity, while the far side is pulled more weakly. That difference in force can deform the object. For Phobos, the problem is that it is extremely close to Mars. Phobos orbits Mars in a little over 7 hours. Meanwhile, a day on Mars lasts slightly more than 24 hours. This means that Phobos goes around Mars faster than the speed at which Mars rotates. Therefore, instead of being pushed farther away like Earth's moon, Phobos is pulled closer to Mars over time. This is an extremely important point. Our moon is drifting away from Earth, little by little, but Phobos is the opposite. It is slowly falling into its parent planet, not falling like a stone, plunging directly toward the ground. It is still orbiting Mars, but its orbit is shrinking. Each orbit is a small step downward, each century a little closer. Each million years, a part of a sentence, written by gravity. Eventually, Phobos will reach a dangerous boundary called the Roche Limit. The Roche limit is the distance at which the tidal forces of a planet can overcome the self-gravity or material strength of a satellite. Simply put, when a moon gets too close to its planet, the side nearer the planet is pulled more strongly than the side farther away. If that difference becomes large enough, the moon can no longer maintain its shape and is torn apart into smaller pieces. If Phobos were a solid block of rock, its fate might be different. It might withstand the forces longer and eventually crash into Mars. But much evidence suggests that Phobos may not be an entirely solid rock. It may resemble a pile of rubble held together by weak gravity and a surface layer of material. If the internal structure of Phobos is truly porous and weak, then as it approaches Mars, it may be torn apart before it has a chance to fall intact onto the surface. And that is when Mars could have rings. Imagine that in the distant future. Phobos enters the danger zone. The cracks on its surface widen more and more. Tidal forces stretch it, compress it, and shake the outer layer of rocky dust. Large rocks begin to break away. Cracks spread like spider webs. Then, during a chaotic phase, this tiny moon is no longer an intact celestial body. It shatters. Part of the material falls onto Mars. Creating impacts with lower velocities than meteorites coming from deep space. Large fragments may produce new craters on the red planet. But most of the remaining material will not fall immediately.
It will continue orbiting Mars,
spreading along the former orbit of Phobos and forming a ring of dust and rock around the planet. From a moon, Phobos becomes a ring. But would that ring resemble Saturn? This is a point that must be clarified to avoid misunderstanding. Saturn has the most famous ring system in the solar system because its rings are vast, bright, and rich in water ice. The ice particles in the rings strongly reflect sunlight, making Saturn's rings brilliant when viewed through telescopes. Phobos is different. Phobos is a dark body with a surface resembling carbonaceous material that reflects light. Weakly, if it breaks apart, the ring around Mars will most likely consist of rocky debris, fine dust, and dark fragments. Therefore, Mars may have rings, but they will not be bright white, magnificent rings like those of Saturn. They may be thinner, darker, dustier, and harder to observe from afar. However, that does not mean they would not be spectacular. If you stood on the surface of Mars during the period when the new ring was forming, Josiah, the sky could look very strange. From suitable locations, you might see a band of material stretching across the sky. During the day, it could appear as a faint streak. At night, under reflected sunlight, it might appear as a dark or dimly bright line, depending on the viewing angle and the composition of the material. Small meteor showers could occur as dust from the ring gradually falls into the thin atmosphere of Mars. Mars would no longer be the lonely red planet with two small moons. It could become a red planet with rings, an image completely different from what we know today. But that ring would not last forever. Planetary rings are not immortal structures. They are influenced by gravity, collisions between particles, sunlight, solar wind, and disturbances from the planet itself. Material in the ring of Phobos could gradually fall onto Mars or be dispersed. Some models suggest that this ring could exist for millions to tens of millions of years, or even longer in certain scenarios. But compared with the age of the solar system, that is still only a temporary stage. In other words, Mars may one day have rings, but that will be only a short chapter in the long history of the red planet. The story of Phobos also leads scientists to debate a deeper question. Where did Phobos come from? There are two major hypotheses. The first hypothesis suggests that Phobos and Deimos were once asteroids captured by Mars. This sounds reasonable because they are small, dark, misshapen, and quite similar to asteroids, but capturing an asteroid is not simple. For an object coming from outside to become a stable moon, it must somehow lose energy. Otherwise, it would simply pass by Mars and continue into space. The second hypothesis suggests that Phobos and Deimos may have formed from debris following a massive impact on Mars in the distant past. An ancient celestial body struck Mars and blasted material into space. That material formed a disk of debris around Mars, and from it, the small moons were formed. If this hypothesis is correct, Phobos is not merely an ordinary moon. It may contain ancient material that once belonged to Mars, and this is why Phobos is so fascinating. It is not only a dying moon. Fascinating. It is not only a dying moon. It may also be the key to understanding the past of Mars. In the coming years, Japan's MMX mission is planned to study Phobos and bring samples from its surface back to Earth if successful. Scientists will have the opportunity to analyze material from Phobos directly in laboratories. From that, we may know more clearly whether Phobos is a captured asteroid or a fragment born from ancient impact on Mars. This answer is very important because if Phobos contains material from ancient Mars, its samples may reveal many things about the red planet in ancient times, a time when Mars may have been wetter, and had an environment very different from the present. But whatever the origin of Phobos is, its future fate is still moving toward a violent ending. The frightening thing is that Phobos does not need a sudden catastrophe to be destroyed. It does not need to be struck by another asteroid. It does not need any explosion. Its current orbit itself is enough to bring it to death. With each orbit around Mars, Phobos loses a little orbital energy. Each century it gets a little closer. Each million years the tidal forces become stronger. And when it gets close enough, Mars will no longer be the planet that keeps Phobos in the sky. Mars will become the thing that tears it apart. This is the tragedy of gravity. The same force that keeps planets orbiting the sun, keeps moons around planets. The same force that keeps planets orbiting the sun, keeps moons around planets, and keeps us standing on the ground, can also be the force that destroys a small world when it enters the danger zone. Seen from afar in the future, the process of Phobos being torn apart may resemble a slow but terrifying spectacle. A small moon gradually deforms. Fragments break away and spread into arcs. Those arcs extend along the orbit. After many revolutions, they close into a ring of material around Mars. From a celestial body named Fear, Phobos becomes the dark ring surrounding the planet of war. Mars may not look like Saturn, but for a time it will bear the remains of a dead moon. And this makes us realize a greater truth. The solar system is not quiet. We often look at planets as stable objects. Mars is Mars, Saturn has rings, Earth has a moon, Saturn has rings, But on the scale of cosmic time, everything is changing. Earth's moon is moving away from us. Phobos is falling into Mars. Saturn's rings may not exist forever, either. Asteroids and comets break apart, moons are shattered, rings are born and disappear. The solar system is a dynamic system, not a still picture. Phobos is only a small celestial body, but its story contains many things. The origin of moons, tidal forces, the Roche Limit, the formation and disappearance of rings, and even the distant future of Mars. In a few tens of millions of years, if nothing intervenes, Phobos may no longer be a moon. It may become a rain of dust and rocks around Mars, part of it falling to the surface and leaving new craters, part of it forming a ring, and part of it gradually disappearing over time. And then the question, will Mars have rings, like Saturn? And the answer is yes. Mars may have rings, but it will not be a brilliant crown like Saturn's. It will be the remains of Phobos, the moon that once orbited Mars 3 times a day, that once bore the gigantic Stickney crater, that was stretched by gravity, and finally torn apart by its own parent planet. A ring not born from beauty, but born from destruction, and that is why Phobos is one of the most remarkable moons in the solar system. It is not large, it is not bright, it is not as famous as Europa, Titan, or Enceladus, but it is telling us a story that few celestial bodies can tell so clearly. Even a moon can have a fate, a lifespan, a decline and an ending written by gravity. One day, when humans set foot on Mars and look up at the sky, perhaps Phobos will still be there, a dark rock racing across the red sky. But in the very distant future, But in the very distant future, that sky may lose Phobos, and instead have a faint ring surrounding the planet. That will be the final relic of a moon that Mars swallowed little by little. Phobos is not plunging into Mars in a single moment. It is falling in silence over millions of years. And in that silence, the universe reminds us that nothing is permanent. Even familiar moons can break apart. Even a planet without rings today may wear rings in the future. And sometimes, the beauty of the universe does not come from peace, but from slow, enormous, and irreversible processes of destruction. Your support will help provide more motivation to continue creating engaging, understandable, and more authentic science videos. Thank you for watching, and see you again on the next journeys through the vast universe.